All right, so this is week 3, day 1. So we have day 1, day 2, day 3, like we did last time. Then we'll take a practice test on that, and then Friday, like I did last time, it's just going to be a free day. So we're talking about domain and range of radical and rational functions. Okay. Now we've done radical functions already, so this equation should hopefully look kind of familiar. Maybe you're like, "Why? I don't remember how to do the stuff in it," but we'll discuss it right now. But the equation y equals to a radical x minus h plus k is the standard form of a radical function. The a term is our amplitude. If a is positive, you can see that the graph kind of opens up. It's kind of like half of a parabola that fell over in a sense, right? So you can see what it looks like, right? If a is positive, it opens upwards. If a is negative, it goes downwards, okay? And then hk is the origin. Some people like to call it the vertex, but not really, because it isn't a high or low point of the graph in terms of a parabola, but it can be a high or low point in terms of this graph. But it's what we call its origin, okay? So here's the next thing that you guys have to basically write down. In your homework, they're going to ask you to find the domain and range of these graphs. Okay, so find the domain and range of the graph or of the function. Okay, so there's 3 steps to doing it. The first thing is you're going to plot its origin. Okay, the HK. Put that on a graph. Okay, second, you're going to sketch it. You're going to draw the curve. And it doesn't have to be perfect, just a quick sketch. Okay, and third, use the graph to find the domain and range. It's actually pretty easy to do domain and range when you have a picture, okay? It's a lot harder to do it when it's just algebraically done. So that's why I have you guys do a picture. And like I said, the picture doesn't have to be perfect, but just close enough, okay? So there are 3 steps. Plot the origin, so the HK. Draw the curve, in other words, sketch it. That's why I put sketch, because I don't want you guys to be like too careful. Just put the points where they're supposed to be and kind of either draw it going up or draw it going down. And then 3, use the graph to find the domain and the range. Okay? And this is, by the way, what we're doing right now, this is the hard part, I would say. The next part in today's lesson after this, the rational functions, that's the easier part. That's what I think personally, even though the problems look worse. So here we go. Identify the domain and the range for that function. So this is what I'm going to do. I'm going to first write down my hk, right? So what's my origin? My h comma k is, well, h is, well, it looks like a -1, so it's a +1, and k is a -5. So that tells me how I'm supposed to draw this thing, okay? I got to make sure I have a 1 and a -5 for y. So let me go ahead and sketch this thing, okay? So, you know what? Since I'm saying sketch it, let's just sketch it like this. I'm not even going to use a nice drawing tool for it, because I'm just going to really quick draw it out. Okay. Now, besides my HK being 1, -5, I need to know which way this thing opens. So I'm going to put A is positive, right? Because A is 4, right? My A is 4. So A is positive. That means it opens up starting from 1, -5. So I'm going to go to 1, -5. I'm going to put a dot right there. Okay? And then, since it kind of goes up, I'm going to just do that. I'm not even going to plot points. I know it's going upwards forever. Okay? Notice the arrowhead. It's going to the right forever. It's going up forever. Okay? So let's put the domain. Now, I don't know if you guys remember, but domain and range are based on horizontal and vertical motion, meaning for domain, how far to the left does it have values? How far to the right does it have values? That's domain. Range is how low does it go to how high does it go. So let's look at the domain. Look at the graph. How far to the left does this thing actually exist? To 1, right? And there's a dot there, so I'm going to put 1, comma. And how far to the right is it going? Infinity, right? So I'm going to put positive infinity. And that's it. That's my domain. Okay. Now my range. How low does it go? To -5 on the y-axis, right? Remember, domain is your x's, range are your y values. So this goes -5. How high is it going to go? Infinity, right? Because remember, it's going to the right and up forever. This is your answer, and we're done. Okay? You just need a sketch. If you look at a picture, you can kind of see from the picture, right? As far to the left as it goes is right here to the left side. X is 1. And then as far as it goes to the right, well, it goes to the right forever. So it's 1 to positive infinity. How low does it go? Well, it goes as low as -5. It's right here, right? -5. And then how high? Well, it just keeps going up forever. Now, you might say, no, it kind of seems to be curling over. But yeah, but the arrowhead means it's doing that motion forever. So to the right forever, upwards forever. Okay? Here's another one. There's only 2 of these, by the way. And then we'll go on to doing 3 of the other type. Now, this one I wrote it kind of backwards. Our k value is in the very front. Okay? So the -1 is your k. Now, if you don't like the way that looks, I would recommend you rewrite it. Okay? So you could always rewrite it as y equal to the square root of x plus 3, and then put a -1 right there. Okay? Now, what's my hk for this one? What's my h value? -3. And my k value? What's my a value? It's 1, right? We can't see it, but it's there. It's in front of the square root. That means that a is positive, right? That means it opens up. Okay? So I'm going to go ahead and sketch this. I need a -3 and a -1, so normal graph kind of works here. Again, I'm just doing this kind of messy. It doesn't have to be perfect. So -3, -1 is right here. Okay? And I know a is positive, so it opens up. Just going to kind of just do this. Okay? So I just sketched it. If it's going downwards, then draw it downwards. Okay? It doesn't matter. Now, domain and range. All right. How far to the left does this thing go? To -3. Right? It's right there. Right at that value. That's -3 in terms of horizontal motion. And then how far to the right? Infinity. So, all right. Now we look at our range. How low does it go? -1. There's a little arrow right there showing you, right? That's how low it went. So -1. And how high? Infinity. Okay. And this is your answer for these type of problems. Now there's 2 types. Okay. There's radicals and then there's rationals. All right. So let me show you the rational one. Now this is the one that I told you. These problems 1 and 2 are the ones that I think are harder to do because you actually have to find domain and range. But for the rational ones, all I need you to do is find just the domain. Okay? So only the domain. So here's what rational functions look like. We've done these before. Okay, hopefully you're kind of remembering like these pictures that we did not too long ago. But y is equal to a over x minus h plus k. If a is positive, then the graph looks like the little green lines right there, right? Quadrants 1 and quadrants 3 occupy the graph. And if a is negative, quadrants 2 and 4 occupy the graph. Okay, and they're bent like that. They have they don't like to touch the x and the y axis based on the original functions. Okay, hk is our center, but remember it's not really so much a center. It's just where we build our asymptotes. Okay, it's where we build our asymptotes. Now the nice thing about doing the problems for rational functions is that we don't have to graph them. That's the nice thing. We just have to look at the denominator, okay? We just have to look at the denominator of the function, and from there we'll be able to figure out our domain. All right? So let me show you the one more thing that you guys have to write down, and then we'll get to the examples. So how do you find the domain of a rational function? You're going to get the denominator, you're going to set it equal to 0. Okay, then you're going to solve it. And then once you solve it, your answer should say, and then I put it right here in parentheses, not parentheses, in quotes, all real numbers such that x is not equal to whatever your answer is. Okay? So it's going to be all real numbers such that x is not equal to your answer. So some of these are really, really simple. Here's the first one. This one's really, really easy. Identify the domain f of x equal to negative 1 over x plus 7 minus 3. Okay? So if I want to identify the domain, I'm going to get the denominator, x plus 7. I'm going to set it equal to 0. Remember, that's step 1. Step 2, I'm supposed to solve it. So when I move the 7 over, x is equal to negative 7. Okay? And then step 3, I'm supposed to write my answer. So here we go. All real numbers such that x cannot equal to negative 7. That's my answer. Now I'm just curious if your teachers have taught you a little bit more than this. Has anybody ever seen this written in a different form? How do you write all real numbers? Anybody know? There's a shortcut for it. Yeah, it's the double bar R, okay? So all real numbers, okay? So this right here is the double bar R. Do you guys know what we use, what notation we use for such that? It's a vertical line. Such that. Okay? So you could actually write this answer, and I would like you guys to get used to doing it, like this. Set notation, okay? All real numbers such that x is not equal to negative 7. That's the same thing. Now, actually, the more correct way to write it would be x being an element of the reals such that, but I would prefer you guys to maybe use this one. This might be a little bit easier to write down because we're using a lot of Greek in the other one, so we won't worry about that. That weird looking E symbol means element of. X is an element of the reals, meaning X is a real number, right? So it's saying all real numbers, okay? And if you want to be even more precise, when you get to college, it actually looks like this. That's what it looks like in college. The upside down A means for all X that are elements of the reals. So all real numbers, okay? So you don't have to worry about doing all of that, okay? But it would be good if you at least kind of do that other one in the box. Might be a shortcut for you. If you don't want to do that thing with the double bar R, that's okay. Just write out the sentence, okay? And it's fine. Nothing wrong with it, all right? But some people want to see shortcuts, so there you go. All right. So 4 and 5, they start to get a little more tricky. But remember I told you, I think these are easier than doing the other problems, number 1 and number 2, right? The reason why I say it's easier is because I don't mind algebra. So doing something algebraically doesn't make me like sweat, okay? I panic more when there's someone says, draw a function for me, right? I'm like, oh man, how did that look again, right? But let's start with our steps. Step number 1, get the denominator and set it equal to 0. Solve it. Now, if you're thinking, well, how do I solve this? This doesn't have 3 terms. No, it doesn't. But they do have like terms, right? They both have an x in common. So x is equal to, x times x plus 2 is equal to 0. I just factored it out. Once you have a product, you're supposed to set each one equal to 0. X equals 0, x plus 2 equals 0. Now the x equals 0 is already solved for, so we don't have to worry about that. So this is just going to be x equals to negative 2. So I have two answers, right? 0 and negative 2. So when I write my answer, I'm going to say all real numbers such that x cannot equal to negative 2 and 0. Whoa, that's not supposed to be a circle. And again, if you want to use that notation, double bar r, vertical line, x not equal to negative 2 and 0, you can. That's fine. So, I mean, that's not terrible, right? As long as you know how to factor, you should be okay. And the last example is just one that's a trinomial, so you got to use the x method. But, I mean, that's as hard as it gets, the x method. Okay? So I prefer rational functions to radical functions when it comes to domain and range. All right, so here's the last one. So here's another rational function. And I know it looks really weird and complicated, but remember what I told you guys? There are 3 steps. First step is just pay attention to the denominator, set it equal to 0. So who cares what the numerator says? Okay, we're just looking at the denominator. Okay, so 2x squared plus 2x minus 12 equals 0. Now I'm supposed to factor this thing, okay, so that I can solve it. Well, let's use the x method, right? A is 2, B is 2, and C is negative 12. Now, if I was you, I would have factored out the 2, but let's not and see what happens, okay? But I would have factored out the 2 to make my number smaller. This would have been a 1, 1, and a negative 6, okay? But if you forget, it's not like it's the end of the world, just the numbers get a little bit bigger. We might have to think a little bit more, but here we go. 2 times negative 12 is negative 24. B is 2. I need two numbers that give me a 24 or a negative 24, but that add up to 2. One is positive, one is negative. Anybody know? Two numbers that subtract to 2 that multiply to 24? Almost looks like a 9 upside down. Yeah, 6 and a negative 4, right? 6 times negative 4 is negative 24. 6 minus 4 is positive 2, okay? Since A is 2, I got to divide it by 2. So this is negative 2, and this is a positive 3, okay? So in this case, when we do this, this is my factor, but this is just kind of a weird situation here. Now, we didn't have any of these before, and this is why I prefer to factor out of 2. You notice there's no like fractions that popped up. Whenever there are no fractions here, because usually we'll end up like a 3 halves or a 5 halves or 2/3 or something like that, and you got to move that number to the front, right? I didn't have to do that here. When that doesn't happen, then you automatically have to bring out the number you divided by, okay? We didn't do any of that before, okay? That's why I like to factor it first, because if I factor it first, this is exactly what it would look like, just like that. I would have factored the 2 out, and then I just would have done the x method for the remaining pieces, which would have been x plus 3x minus 2. So it's just more complicated when you get a little lazy and you don't factor things out, right? It's better to simplify as you do the work. So, but yeah, so again, why did that 2 pop up in the front? Because there were no fractions as factors, right? Normally we'd have a fraction right here where the -2 is, then maybe that was a fraction of a 1/2, right? Normally we'd have a fraction there somewhere, but there were none. They got wiped out because everything divided evenly. So when that happens, whatever you divided by has to hang out in the front, okay? So now my two solutions are x plus 3 equals 0, x minus 2 equal to 0. So now we have, moving this over, that's x equal to -3. If I move this over, x equals to 2. So I get two solutions. So these are the answers I cannot use. So I'm going to write all real numbers such that x cannot be -3 and 2. And again, if you want to write it like this, that's okay. It's just another way to do it without so many letters and words, right? But this is what your homework is going to be like. You're going to be finding domain of rational functions, domain and range of radical functions, okay? For the radical functions, you're going to want to draw. It's easiest that way. For the rational functions, just get the denominator, set it equal to 0, and use your skills of factoring, okay? Maybe you factor just one number out. Maybe you factor just one letter. Maybe you got to do trinomial factoring, meaning X method. Maybe you have to do a difference of two squares. I'm not sure, but we're going to be factoring for the rational stuff. So let me go ahead and pause this thing, and then I'll give you your homework.